Hello everybody, welcome into another lesson. So today we are going to talk about Heron's formula. So this formula is for also finding the area of a triangle. Now, if you are given three sides of a triangle, all three sides, if you know them, you can use this formula. And it doesn't have to be a right triangle, you don't have to draw any altitudes in a triangle, you can just straight up use the formula. So the formula is the area equals the square root of the quantity of s times the quantity of s minus a times the quantity of s minus b times the quantity of s minus c, where you have sides a, b, and c in your triangle. So you're probably wondering, well, what the heck is s? That's your semi-perimeter or half perimeter of the triangle. The idea is you're going to get s, you'll take your three sides, add them together, and divide that by 2 to get your s. And there's no trig involved in this formula, so really it's actually going to be easier than using that formula we had yesterday when we found the area of triangles using that based on the law of sines. So let's get started with some examples here. Alright, so we'll just draw ourselves a nice happy little triangle again. Triangle A, B, C. Let's see what we have here. Side A is 4. Side B is 2, and then side C is 4. So you have a triangle where you know all three sides. Well, first thing I'm going to suggest is you find your s. So you'll take that 4 plus that 2 plus that 4, divide all that by 2. 4 plus 2 is 6 plus 4 is 10, divided by 2 is 5. So s is 5. That's easy enough. Now what I'm going to suggest before you go putting all this into your square roots, make your life easier. Find your s minus a, your s minus b, and your s minus c outside of the square root first. So s minus a, okay, so that's going to be 5 minus 4, which is going to equal 1. And then find your s minus b. Well, that's going to equal 5 minus 2, which would be 3. Then find your s minus c, which is also going to be 5 minus 4. That's going to equal 1. So now just take all these, put them into your square root. So the area is going to equal the quantity of your s, which is 5, times your s minus a, which is 1, times your s minus b, which is 3, times your s minus c, which is 1, which would give you the square root of 15. You could leave it like that, or if you want a decimal approximation, we can certainly find that. So let's go ahead and find that, the square root of 15. You get about 3.87. So the area of this triangle is approximately 3.87 square units, or the square root of 15 square units, however you prefer to write it. So I got 3 more examples of this. This is relatively a straightforward formula. It's really not that bad. Alright. A is 8. B is 8. And C is 8. So all three sides have a length of 8. I don't know why I wrote B there. So we actually have an equilateral triangle. Well, even better. So to find our S, we just take all 3 8s, add them together, divide them by 2, you would get 24 divided by 2, which is 12. So your S has a value of 12. Now let's find S minus A. That, of course, would be 12 minus 8, which would be 4. s minus b is going to be much the same. 12 minus 8, you would end up getting 4. And then your s minus c is going to end up being 12 minus 8, which is also 4. So now we can apply the formula. Area equals the square root of the quantity of that s, which is 12, times your s minus a, which is 4, times your s minus b, which is also 4, times your s minus c, which is also 4, which is going to give you the square root of a really large number. Let's figure out what the heck that is. That'd be the square root of 768, which we may be able to simplify the square root. You may want to still simplify it because your answer may appear that way and your teacher may not want a decimal approximation. Alright, so this would break down into the square root of 64 times 12, which would be 8 times the square root of 12. Well, the square root of 4 breaks down to the square root of 4 times 3, so this would break down into, you would get an area of 16 times the square root of 3 units, or you can get a decimal approximation. So the area for sure is 16 times the square root of 3 units if you wanted an exact, or an approximate would be 27.71 square units. So if your teacher wants an exact, it would be 16 times the square root of 3 units. If they want an approximate, it'd be 27.71 square units. And I got just 2 more, and then we're done with the lesson. Alright, so what do we got here? A is 13, B is 10, and C is 4. Alright, bigger numbers and all different lengths. So let's find our S. That, of course, is going to be our A of 13 plus our B of 10 plus our C of 4. All that divided by 2. Which really is just going to end up giving you 27 divided by 2, which honestly is probably just, well, we'll just leave that as it is. So now let's find S minus A. That's going to equal 27 halves minus your A of 13. Well, 13 is 26 halves, so your A would be 1 half. Your S minus A is 1 half. How about S minus B? So that's going to then be 27 halves minus your B of 10, which is also 20 halves. So you would get 7 halves for S minus B. Then what about S minus C? That's still going to equal your 27 halves minus your C of 4, which we know to be 8 halves, so that would be 19 halves for S minus C. Now we can just take all this and put it into the square root. So area would equal the square root of your S, which is going to be 27 halves, times your S minus A, which is 1 half, times your S minus B, which is 7 halves, times your S minus C, which is 19 halves. Alright, so this is going to then turn into, we'll have 2 square roots, one in the numerator, one in the denominator. That's 2 to the 4th, which is 16 in the denominator. square root of 16. Now let's figure out what this ugly numerator is going to be. $3,591. So we have the square root of 3,591 over the square root of 16, which we know that denominator will turn into 4. But let's see if we can simplify 3,591 any further. Well, you would end up definitely getting 3,000. Let's see, that would simplify into 9 times, not 399, so that would be 3 times the square root of 399 all over 4. But I don't think 399 breaks down any further. Nope. So we're stuck. So the area for sure equals 3 times the square root of 399 over 4 if you want an exact result. Or you want to take a decimal approximation, we can do that too. You get an area of approximately 14.98 square units. That's about what that would equal. So the area is exactly 3 times the square root of 399 over 4, or approximately 14.98 square units. And we got one more, then we're done. All right. A is 15, B is 20, C is 25. All right, so let's see. A is 15, B is 20, C is 25. So let's find our S. That would equal our A of 15 plus our B of 20 plus our C of 25, all divided by 2. Well, the numerator, so that would be 60 divided by 2 then, which would be 30. So your S is going to equal 30. Now let's find S minus A, which would be equal to 30 minus your A of 15, which is equal to 15. Now let's find S minus B. So that's equal to 30 minus your B of 20, which would end up being 10. Well, then let's find S minus C. That's going to equal 30 minus your C of 25, which would just be 5. All right, now that we got everything, let's put this into the square root. So the area would equal the square root of our S, which is 30, times our S minus A, which is 15, times our S minus B, which is 10, times our S minus C, which is 5. So let's see what we get here. It's going to be a big number, that's for sure. Get the square root of 22,500, which I know is going to simplify further. Now, let's see what we get here for that. That would break down into the square root of 100 times the square root of 225. So that would end up starting out with 10 times the square root of 225. Well, it just so happens we'll have a perfect square root, because the square root of 225, that breaks down into 10 times the square root of 9 times the square root of 25, which would be 10 times 3 times 5, which would give you 150. So the area would be exactly 150 square units. So that's it for Heron's formula. The next lesson we're going to get into something called parametric equations, which I think are really neat. We'll get into those. So I hope everyone has a great day. Take care.